students or friends. We are going to solve a problem from Jest 2022. So here is a question given, that is a system with two energy levels is thermal equilibrium with a heat reservoir at a temperature 600 Kelvin. The energy gap between the two levels is 0.1 volt, and if let P be the probability that the system is in the higher energy state, then which of the following options will be correct? So here there are two systems. The system 1, that is a lower level energy level E1, and the higher energy level at E2, and there is the distance between, or the gap between the two energy level is 0.1 electron volt. Now we have to find the probability that what is the probability that the system will have this energy state, and what is the probability that the energy state will be in the higher energy state. So we have to find the higher energy state. As we know the formula to find the probability. The probability is PR equal to GI e to the power beta epsilon I by Z, where this is the G is a degenerate state or degeneracy, and beta, where beta is the inverse temperature 1 by kT, and epsilon I is the energy state, where Z is the partition function, which is equal to e to the power minus beta epsilon 1 plus e to the minus beta epsilon 2. Here epsilon is the energy states. So partition function, we can write the partition function as e to the power, that is E1 by kT plus e to the power minus E2 by kT. We have write the partition function for two energy states, and there is the degeneracy is taken as 1. So now we have to find the probability that the particle or the system is in the higher energy state. So the probability becomes higher energy state. We are having the higher energy state. We can write the energy in the higher energy state as e to the minus E2 by kT divided by e to the power minus E1 by kT plus e to the minus E2 by kT. So we will have, if I take this, so the numerator part to the denominator, we can write this equation as 1 plus e to the power E2 minus E1 divided by kT. E2 minus E1 divided by kT. Here E2 minus E1 is given as 0.1 electron volt, and here given P is given as 600 Kelvin, and we know the Boltzmann constant K equal to 1.38 into 10 to the minus 23 joule per Kelvin. Now see, here the energy is given in the unit of electron volt, but the Boltzmann constant is given in the unit of joules per Kelvin. If we convert joule into this, that is 1.38 into 10 to the minus 23 divided by, if we divide it with the charge of the electron minus 19, we will give electron volt per Kelvin. That will give 8.625 electron volt per Kelvin. So we have to use the value of K in this equation. Now I'll erase this one and find this solution. Now see, now putting the value of P of R equal to 1 by 1 plus e to the power, how much I have to put, the value have to put, that is 0.1 divided by, what is the value, 600 into 8.625 into 10 to the power minus 5 into 10 to the minus 5 electron volt. So probability would be like 1 by 1 plus e to the power 0.1 into 10 to the power 5 divided by 600 into 8.625. If we calculate this with a calculator, we will get P of R equal to 0.12, and this value is lies between these options. That is, it is varies from 0.1 to 0.2, that is 0.12. So our final answer is this one. Thank you for watching.